welcome to my YouTube channel. So here today we are going to be looking at the introduction to circular motion. Mostly we are going to be looking at the conical pendulum. So this is a conical pendulum like that. We are going to solve all these problems to equip you for your test. So now, one of the most important things that you should know is we have the centripetal force. So the centripetal force, so this is the force that keeps an object rotating in a circular motion. So this is basically the simple definition of what centripetal force. So it is a force that causes an object to be able to move in a circular orbit or rotation. So like for example, we might have a force being applied here, then we have an object, then it's moving like that. So that is what we call, so this force, the one that is causing. So if there is a person here who is holding, let's say, a string here, then this string, so this is what we basically call circular motion. So it will be able to be rotating like that. So it will be able to be moving in a circular circle. So the one that is producing this circular motion in this case is a person who is applying the tension force like that. So this is basically what the centripetal force is. The other important knowledge that we need to know is that what is the angular velocity, or rather how do you calculate the angular velocity? So the simple relationship between the angular velocity and the velocity is that when you're looking at the angular velocity, it will look something like this. So the relationship is such that we are going to have our, let's say our velocity is equal to the radius times the angular velocity. So this is the symbol where this is the angular velocity. So this is the angular velocity like that. Now what you need to know is that, so this is the radius, then this is the velocity. Another formula, if you are looking at this distance, or distance is equal to r is always common times the angular displacement. So this is the angular displacement like that. So now this, in terms of this, can be measured in radians. Now this is if you have a circle like that, from your math you will realize to say the total distance covered by the circle is this angular, it's an angle, so it's angular displacement. So in a circle, the distance is substituted by the angular. Why the angular? This is simply because it is more like it is making an angle while trying to rotate like that. So the angular velocity for a circle, it will be equal to 2 pi like that. So this is a complete circle. This is 2 pi is 360 like that. So it will be able to move 360 to complete a circle like that. So therefore, if you are also required to derive the other formula, we are going to have something like this. Remember, when we are looking at so it's still the same. If you have the distance is equal to the speed, let's say this is speed is equal to distance over the time. Now what is the distance in this case? For the angular form, where there is speed, or if we have velocity there, where there is speed, you are going to say the angular velocity. So it is still the same formula. Now instead of putting distance, you are going to put the distance in terms of a circle, which is your angular displacement, which is like this, then over the time. Now what is this time? So the time it takes to complete one revolution is called the period. So this t is the period. So this is another formula. So this is the period like that. So therefore the angular is equal to, what is this theta? Remember, this theta is equal to, we have 2 pi. So we are going to say 2 pi like that over the period. Now if you recall, we have the angular should be equal to 2 pi. This is the same as times 1 over this. 1 over this is the same as 2 pi over this. Now 1 over the period is the same as having, we are going to have, remember, 1 over the period is equal to the frequency. Likewise, frequency is also equal to 1 over the period is frequency. Likewise, even period also. Period is equal to 1 over the frequency. So they are equal to each other, they are the inverse of each other. So this makes your angular velocity to be equal to 2 pi times the frequency. 1 over this is the frequency. So this is another formula like that. Now with this said, so we are going to be using all these formulas. So this is how you find the angular velocity. So this is another formula for angular velocity. Now likewise, if we are looking at another formula or another alternative, if you are looking at the angular frequency is the same as the angular velocity. So if they tell you that angular frequency, it is the same as the angular velocity. The only difference is that angular frequency is taken as a scalar, meaning to say for angular velocity, you are interested in how it is moving, which direction is it moving. Is it moving like this? Is it moving like this in a clockwise direction? Or is it moving in a counterclockwise direction like that? So this is clockwise, then the other way is counterclockwise like that. So due to that, that is what we call angular frequency. They are the same in terms of the value, but it's only the direction. Then differentiate when you are asked rotational motion. So this angular frequency, by formula, even the symbol is the same omega like this. So it is, the angular frequency is equal to 2 pi if you want over period, or if you want W should be equal to 2 pi by the frequency. Then alternatively, the rotational frequency is the number of cycles per second. Remember, so that's the difference. Period is the time taken per the number or to complete one oscillation, or then for frequency it is the opposite. It is the number of cycles made in a period of time like that. So that is the difference. Rotational frequency, if you are asked, if you have, let's say, the omega, or you have the angular velocity, it will be equal to 2 pi f. You are now conversant with this formula. So rotational frequency is this is the rotational frequency. So if you divide 2 pi over 2 pi, then it becomes your omega over 2 pi should be equal to the frequency. So this is the formula for the frequency. This is the formula for the frequency, rotational frequency. Then angular frequency, remember, it is equal to 2 pi of the times the frequency, or if you want, it is omega will be equal to 2 pi over the period like that. So with that said, I think that's all the knowledge that we need for us to start answering some problems. But before that, let's deal with how we are going to be deriving. So if you have the pendulum like this, you have something like this. So this is what we refer to as a conical pendulum, which is the videos that we are going to be, the video we are going to be solving today. So it will be moving like this. So this is the conical pendulum like that. So as you can see, it is attached at that point. So it is attached to the string. So just imagine it was attached, then it is moving like that. So that is a conical pendulum. It makes a cone like that. So now in a conical pendulum, there are things that you're supposed to know. So let's begin. So these things that you are supposed to know are, firstly, when I do this, the angle will be here. So we have the angle theta here. Then the opposite, remember, anything that has to do with the opposite, it shall carry sine theta. Whatever is not the opposite, it shall carry the cos. So in this case, this side, it will be the cos. So let's say the tension is the force exerted on the string. So this will be tension. So we are going to say tension, sine of the theta. Why sine? Because this angle is pointing this direction. So it's always that. Then if the x direction is the sine, then automatically the other one shall be cos. So we are going to have our t cosine of our angle theta, like that. So this is basically the angles that we have: t sine of theta, t cos of theta, like that. So this is very important. Then the one that will be acting downwards on an object is the weight of the object, and we know that the weight of the object is equal to mg. So we just write mg. So we have the downward force is mg, like that. So now if you look, the centripetal force is the force that it is the force that causes an object to be in a circular orbit, if you remember that definition. So in this case, as you can see, this t sine of theta is the one that is pointing inside. That means to say it provides the centripetal force. So that means to say, for us, we are going to say the summation of forces, let's say in the y direction, is equal to 0. So this is a conical pendulum, meaning to say it is only that we cannot see it as a 3D, but it is maintaining the same horizontal height. So it is like this. Then it is just a circle that is passing like that. It's not that it's a different position. It is maintained. It is just that if I was to draw a 3D, it would look like this. Just think of all this as being the base. So all these points, all these dots are the base, and they are level with this. So the summation of forces in the y for a conical pendulum is equal to 0. Why 0? This is simply because it is not moving in terms of the x, in terms of the y direction. So it will not go at a higher level. No, even when you look at these red lines, all these red lines, they are just on the same level as this point. It's only that drawing would be difficult, but that's the way it is. So the summation of forces in the y is equal to 0. Now, which forces are those? The one that is pointing up is the t cos of the theta. Then the one that is pointing down is the h, so we say minus mg is equal to 0. So this is always the case for a conical pendulum, like that. So the cos component is the y one. So we are going to be just using t cos of theta minus mg in our examples. So this is what we have, like that. So that means to say, if we are making t cos theta the subject, it will be t cos of theta, then the mg will cross the equal sign. It will be equal to mg, like that. Likewise, if we look at the summation of forces in the x, remember the one that is acting in the x, it is still maintained that this is the x, this is the y. The one acting in the x is the t sine of theta. So now this is trying to keep the object in the center, more like it wants to pull the object to the center, so it keeps the object moving in a circular path. So it provides the centripetal force. Remember, centripetal force is the force that causes an object to move in a circular orbit. So we are going to say this should be equal to our mass times our centripetal acceleration. Now, why MAC? Because the force will be equal to force, and we know that force is equal to ma, so that's why we have ma. C now, AC is the centripetal acceleration. So this is basically the formula. Formation of summation of forces in the x direction is equal to that. So we are going to have the only force that acts at this point is the one that's producing the centripetal force. Here is T sine of theta. So we are going to say T sine of theta should be equal to MAC, like that. So these equations will be very, very, very important and very, very cardinal. We haven't solved any question, but yeah, we are just deriving some formulas that are useful. Likewise, the length of the string is equal to the length L. So it is equal to the length L. Now this length L has got a side which is, remember, from the circumference, from this point to the middle point, it is going to be, what we are going to have is the radius. So the radius is from the circumference, any point on the circumference to the center, it is the radius. Now the radius is equal to, we are going to have our radius, which is equal to, now if you see, this is L, this was T. So whatever, if we have the angle here, whatever side is opposite to the angle, it shall carry sign. So the radius will be equal to, now together with the L there, so it will be equal to L sine of our angle theta. Why sine? Because it's the opposite. So this is also very important depending on how much information you have. So with this derived, let's answer some questions. So let's begin with one that does not even use the knowledge that we have discussed, but others, the 5, will be using. So let's begin with this one. If we have the conical pendulum, a ball of mass 0.5 kg is attached to the end of the cord 1.5 meters long. The ball is whirled in a horizontal circle. So horizontal circle, already that gives you the fact that it's a conical pendulum. If the cord can withstand the maximum tension of 50 newtons, what is the maximum speed at which the ball can be whirled before it breaks? Then this important information says, assume that the string remains horizontal during the motion. So it means, let's say, if we don't know how it is, but it can be like this. Now remember, for a conical pendulum, it looks like this. So this is not an ideal conical pendulum. It means to say the force is acting like that. So it is just at 90 degrees like that, but it is making a horizontal circle like that. So it is making a horizontal circle like that. So it is not down like this, so that we can get the angle theta and resolve into components. Be very careful when you just hear the word. It is perfectly horizontal. It means to say the angle, it is at a 90 degrees angle. This could be a person like this. So you will find that the person will be moving like this. So it will be moving like this. So it is just, if his head is here, it will just be moving his head like that. But just for the sake of a 3D diagram, that's how come it looks like that. But in the actual sense, it's not moving from this point. It will be at this point, at all points like that. So this is what we call an horizontal. It is kept, assume that the string, so it is the string is kept horizontal. So now this means that the one that produces the tension is just the tension is the one that produces the centripetal force, because tension is the force that is being applied. So any force that is being applied to cause an object to move in a circular motion is what we refer to as the centripetal force. So in this case, we are going to say the tension. We are going to say the tension like that. So therefore, we are going to say, remember, if it is the tension, we are going to say the summation of forces should be equal to 0. Here we are not going to consider, if it is horizontal, we are not even going to consider the downward force. What is it balanced by? No. We only consider that when it is at an angle, which we will solve most of the problems. So in this case, we are going to say the one that is producing the centripetal force is the tension. So we are going to say the tension is the force, which will be MA. Remember, the formula says force is equal to MA. Now, which force is that is producing the centripetal force? It's this tension, should be equal to MA. Then we are told that the ball is whirled in a horizontal circle if the cord can withstand a maximum tension of 50 newtons. What is the maximum speed at which the ball can be whirled before the cord breaks? So the maximum tension is 50 newtons. So this is what we are going to use. So we are going to say, so one thing that I didn't mention is the centripetal acceleration is equal to the velocity squared over the area. So this makes it tension should be equal to mass, where there's the centripetal acceleration, we have v squared over r like that. So this gives us a value of the tension. So we are going to cross multiply tension times the radius. It will be tr should be equal to v squared m v squared. So we have multiplied t times r. That's how come we have tr. Then we divide, we want to make v, we want the maximum speed, so we leave v alone, so it will be over m. So we are going to get, so we are getting the values such as our tr over the mass should be equal to v squared like that. Then we are going to have our square root. This gives us a value of v should be equal to the square root of tr over the mass. Then our velocity will be equal to the square root of what is our tension. Our tension, the maximum tension is 50 newtons times what is our radius. So for a horizontal circle that is not at an angle like this, whatever is the length of the cord or the string becomes your radius. Because if let's say, if you are here, if let's say this length from here up to here is 5 meters, that means to say even from here up to here it will be 5 meters. So in short, that forms your radius because it is not at an angle. So the simple illustration that I can give you is, let's say if you are to start, you have a string like this. So this will be your radius because when the circle is being formed, it will be able to be equal at all points. It will be able to be equal at this point, at this point, at that point. So that is what we call the radius. From the center, it will just be the same like that. So our 50 times, we have 1.5. Then we divide by our mass. So our mass for this is equivalent to 0.5 kg. So we have our 0.5 kg. So our v should be equal to, we are going to have our 50 times 1.5. This gives us a value of 75. So we have the square root of 75 over 0.5. So when we divide our 75 divided by 0.5, it will give us 150. And our square root of 150 gives us a value of our 12.25. So this will be our meters per second. So we have found the speed like that. Then, considering the second part says, suppose the ball is whirled in a circle of a larger radius at the same speed v. Is the cord more likely or less likely to break? So you are going to say, you know that your tension is equal to, we have our mass, velocity squared over the r. So this was the normal tension. Now they are asking that you maintain the velocity. Which one will be able to withstand more? Will it withstand more or not? Let's say you say T2 is equal to our mass velocity squared over the major R. Now get this. The maximum tension to be reached, the maximum tension here is 50. That means to say we can have, let's say the radius that is producing this 50 is 1.5. Is 1.5. Let's see what happens. So this will not be part of your calculations, but it's for the explanation. So it will be, tension should be equal to, we are going to have, what is our mass? Our mass in this case is 0.5 times our velocity squared, which is 12.25 squared over the radius. It was 1.5. So this gives you the tension of, so we have 0.5 by 12.25 squared, then divided by our 1.5. This gives us the 50, exactly the 50 newtons. So with a radius such as 1.5, we are going to have 50. That means to say we have reached the maximum at which the rope can be able to snap. But what if we increase T? So we maintain everything, 0.5 times the speed 12.25 squared over, what is our radius? Let's say our radius is increased to, let's say 20 meters. So the tension will be equal to 0.5 by our 12.25 squared, then we divide by our 20. So when we divide by our 20, it will be equal to, the tension will be equal to 3 point. So we have our tension will be equal to 3.75 newtons. So remember, even if you increase the radius, the same tension, the maximum tension that can be reached is 50. So as long as you increase the radius, the cord will be less likely to snap, because the tension applied will be reduced, not the maximum tension, but the tension applied will be reduced. So you can say, so this is how you represent your answer. So you say T is equal to m v squared over our r. So then our T1 or our T2 should be equal to the one with the increased tension, will be equal to mv squared over r. So you can be able to say increasing the radius reduces the tension applied, not the maximum tension, but the tension applied. Therefore, so even the equation itself, you can see that tension is on top, radius is down. So you can just say the tension is inversely proportional to the tension applied is inversely proportional to the radius. That means increasing the radius would consequently reduce the tension, which means that it will be less likely to snap. So that is how you represent your work, like that. So now let's move on to our next question, where we have to use the knowledge that we discussed here. So let's begin. So consider a conical pendulum with a 50 kg bob on a 5 meter wire, making an angle of 10 degrees with the vertical as shown in the figure below. Determine, for A, we have the horizontal and vertical components of the tension in the wire. Then our B, we have the centripetal acceleration of the bob. Our C, we have the speed of the bob. So here, what we are going to have is that we are going to say for our A, we have the horizontal and the vertical components of the tension in the wire. So remember, we have the the theta is there. So when we have something like this is where now we use. So this, the opposite of this will be the T. Remember this, there will be a tension on the chord. So we have T sine. So as long as the angle is opposite, it will be sine of theta like that. Then on top here, it's not about memorizing, it's about knowing. As long as the angle is opposite, you use sine. Then up here, it's not that always the y component will be your sine, no. So this will be, if this is sine, this will be cos. So T cos of theta like that. So these are the forces. So as you can see, you are able to say they want the horizontal and vertical component. So you are going to say the horizontal component, okay, let's begin with mostly, okay, so we have the horizontal component will be the T sine of theta. Now remember, this is the one that is trying to pull the objects to the center of the circle. So this will be equal to, we have the T sine of theta. This will be the one that will be equal to the centripetal acceleration, which will be your MA times your C, which will be equal to T sine of your theta should be equal to mass. Centripetal acceleration, remember, is V squared over your R. So this gives you this equation. Therefore, if this is the equation that it's giving you, then you are going to, so this is the horizontal component. So let me just reduce the thing so that I'm able to write a lot, so that I can just be comparing between the two and see which one are you going to start with, depending on the amount of information that you have. So if you look at this, so we have the horizontal component, then we are supposed to figure out which one are we going to begin with. We also have the vertical component. So the vertical component is the T cosine of theta in this case, because it is the one that is pointing up. So this is equal, so remember, the downward force in this case is the mass times the gravity. So we have minus, so summation of forces in the y is equal to 0. As you can see, it's maintaining this level. So even if you see here, it's not like it's going up, it's just a circle. It's purely a circle like that. So we are going to have minus the downward force is the mg, so we have minus our mg is equal to 0 like that. So we take this the other side, so it will be T cosine of theta should be equal to our mg. So now the vertical component is equal to T sine of theta. Don't get it confused. This is the whole of this, even including the angle, is the vertical component. The whole of this is the horizontal component. It's not that you are going to answer for tension, no. You are answering, that's whatever it will give you for T cosine of theta. Remember, the vertical is the one that is going up, and the one that is going up is actually the whole thing, the T cosine of theta. So we are going to say the horizontal component, which one is easier? We have the mass, we have the gravity. Here we don't have the velocity. So it will be a bit difficult to find. Do we have the mass? We have the mass, it's 50 kg. So we can be able to answer the vertical component with ease. Then after we find the vertical components, we are going to be able to answer the horizontal component. So we are going to say vertical component. So beginning with the vertical component, which is our T cosine of theta, should be equal to what is our mass. Our mass is 50 kg times our gravity is 9.8 newtons per kg. So this gives us a value of, if we press our 50 by 9.8, 50 by 9.8, this gives us a value of 490. So we are going to have our 490 newtons. So this will be our vertical component. Then to find our y component, this, remember, this is your y component. So we can say, or should I say, sorry, not the y component, this is your horizontal. We have the vertical, this is the horizontal. So the horizontal is, we don't have the velocity, but we have found the tension. We have found not the tension, but we have found Tcosθ is equal to 490. So the horizontal component, it is not equal to, it is not like mt sine of theta is equal to mv squared. Not really. Even here, the horizontal component is just equal to t cosine of theta. So in this case, the horizontal component is equal to our t sine of our theta. So this is our horizontal component. We can find what this is equal to by substituting, but we don't have the velocity, so we are required to use another way. Since we can find the tension, this tension, we have 490, which is the whole thing including the angle. So therefore, we ask ourselves what angle is made. We are told that the angle, an angle of 10 degrees. So we are going to say the tension. So don't get it confused. So this is your vertical component. Now find your tension so that you can use it there. So we have t cosine of theta should be equal to 490. So the tension, you divide the cos of theta so that the tension remains alone, cos of theta. So this gives us tension should be equal to 490 over the cos of theta. We have the tension should be equal to 490 over the cos of, what is our theta? Our theta in this case is equal to, we have been told that it's 10 degrees, so our tension should be equal to, we have our 490 divided by our cos of 10 degrees. So this gives us a value of 497.56 newtons. So this is our tension. Then we are going to use this tension to find the horizontal component. Remember, the horizontal component is this whole thing. So we can be able to say the horizontal component will be, what is your t? Your t is 497.56. Then we have the sine of the angle 10 degrees. So this gives us a value that is equivalent to, we have the 497.5 with a sine of 10 degrees. This gives us a value of 86.39 newtons. So therefore we are going to have our horizontal, let's just name them horizontal component should be equal to, this was the 86.3, so we have the 86.3 newtons. Then the vertical component should be equal to, we found this as our vertical component. Our t cosine of theta was found to be 490, so we have our 490 newtons, like that. So with this video, kindly like and subscribe if you haven't subscribed, so that you don't miss out this very powerful content. So with that, we have our next one, which is saying that, where is it? We have this other one. So it says that the centripetal acceleration of the bulb. So remember, centripetal acceleration can be found as v squared over r. This is one way. The centripetal acceleration is equal to v squared over r. But what if we can just substitute? So remember, the one that is causing the centripetal acceleration is the t sine of theta. So we can be able to say t sine of theta is equal to mass times the centripetal acceleration. The The centripetal acceleration is where we replace the v squared over r, but we are not finding v, so we can just leave it as our AC. Now we already know what this value is equal to, t sine of theta. T sine of theta is equal to the 86 we found. So in other words, the horizontal component is the one that produces the centripetal acceleration or the centripetal force. So we have our 86.3 newtons should be equal to, before that let's just divide in advance over our mass. This gives us a value that is equivalent to, we have our t sine of our theta over our mass should be equal to AC. So our AC should be equal to, we have what's our tension. So our t sine of theta, if you want you can replace the 497, then again you say sine of 10, but you already know what the t sine of theta, the whole value, is equal to. It's 86.39. so we are going to put that 86.39 newtons over the mass, which is equal to, we have what's our mass. So our mass here is 50 kg, so we are going to get the 50 kg like that. Then our AC will be found to be, so 86.39 divided by our 50, this gives us a value of 1.73. Then we have our meters per second squared, so those are the units for centripetal acceleration. So this is our value. This other question says that consider a conical pendulum. Foresee now the speed of the bob. So remember, the centripetal acceleration is equal to v squared over r. Now be very careful, we don't have r, but we have the length. We have 5 meters, so the length of the wire is 5 meters, making an angle of 10 degrees. So we are going to have our AC. What are we going to do? So we are going to have our r. What can we substitute for r? So remember what we did at first. So if we have such a thing, we are going to have something like this. We have something like this. Now remember, it is something like this. Now if the angle is here, the r is here, so then the length of it is this is our length. So we are going to say the r will be equal to, since this is the length from here up to here, and the angle is here, it will carry the sine. So we have our L sine of theta. So where there is r, we are going to put L sine of theta. So we are going to have our L, so our AC should be equal to v squared over, where there is r is equal to L sine of theta. So we have our L sine of our theta, which gives us our acceleration. If we cross multiply acceleration times this, it will be acceleration L sine of theta should be equal to v squared. So from that we are going to now find the square root so that we can make v the subject of the formula. So our AC times our L sine of theta should be equal to v like that. So we have the root of, what's our AC? AC is found to be 1.73 times what's our length. So the length of this is given as 5 meters. So we are going to say 5, the length has to be in meters. Sine of the angle is 10 degrees. So the angle is 10 degrees should be equal to v. So we press our 1.73 times our 5 sine of 10 degrees. This gives us a value that is equivalent to 1.5. So we are going to have the root of 1.5 should be equal to v. We find the square root of this, it gives us 1.23 should be 0.23 meters per second should be equal to our velocity like that. So this is basically what our velocity is equal to. So if this is our velocity, therefore we can now be able to in fact, this is our velocity, or rather the speed. So the speed is equal to 1.23 meters per second. So this is the first alternative. The other alternative that can be used is we know that the one that provides the centripetal acceleration is the tension. So remember, T sine of theta is equal to mass times the centripetal acceleration. Let's say you are not given the centripetal acceleration. You are going to say the T sine of theta is equal to m/ac, and we know what ac is equal to. It is equal to m. Our ac is v squared over r. So we have our tension sine of theta like that. So we know that our r is equal to L sine of theta. If we had r, we can just replace direct, but we don't. So we have T sine of theta, we cross multiply, times our r should be equal to mv squared. So we have over m over our m like that. Then our v squared should be equal to T sine of theta times our r over our mass like that. So we have the square root, we have our square root like that. So we have our v should be equal to the square root of our tension sine of our theta times our r over the mass. So we have the velocity should be equal to the square root of what is our tension, T sine of theta. Remember, we found T sine of theta to be equivalent to, so if you recall, it was equal to 490. So T sine of theta was found to be equal to 86.39. So you already have that. If you don't have, you replace 493 sine of 10. That is what you do. So we are going to have our 86.39 times what is our r. Our r is equal to our L sine of our theta. So if you want, you can find r, then just replace anything is okay. So we have 5 sine of our 10 degrees over what is our m. Our m is equal to, what's our m equal to? So our m is 50. So we divide over our 50, and our value is v should be equal to our 86.39 times 5 sine of 10. This gives us 75 divided by 50. We are going to get the root of 1.5, which v should be equal to, if we find the root of this, it is going to still give us 1.224 or 225. But let's say root of 1.5 is basically 1.225 meters per second. So either you do that or you do this. Let's move on to our next question. So we have this one. The figure below shows a conical pendulum with a bob of mass 5 kg. The bob revolves in a horizontal circle of radius 1.25 with a period of 3 seconds at a constant speed. Find the tension in the string. Now immediately they give you the period, just not to say something that has to do with the velocity or the angular velocity is very important. So first let's write what we know. So we know that the downward force is mg, the upward force is our t, since the angle opposite here will be able to produce the t cos, not cos but sine, since sine is the opposite sine of theta. Here it will be sine cos of our theta like that. Then, so this is what we basically have. We have that. Then, looking at this, we are going to come up with the equations. By now we understand that T sine of theta is the one that produces the centripetal acceleration. So we have our MSc. Then the T cosine of theta, you can say minus the downward force, which is your mg, should be equal to 0. So that means your t cosine of your theta should be equal to mg, like that. Now look at the amount of information they have given you. They want the tension. You don't have the centripetal acceleration. You don't have the angle. Are we given the angle? Even the angle, you don't have the angle. Then also here, you don't have the tension, you don't have the angle. So that means to say you cannot be able to use it directly. So what are we going to do? So knowing that there's the period, and we know that the acceleration can be equal to the velocity squared over r. That means that the tension sine of theta should be equal to mv squared over r. That's the centripetal acceleration. Now why have we converted it to this form? This is simply because we are given the period. It means to say there is a way to move from the period to find the displacement. So provided with a period, if you recall that formula that we introduced at first, we said that the velocity is equal to r times the angular velocity. So never forget this formula, very important. So for whatever you're looking at, just put r. As long as it's the angular form, just put r times that angular form. If it's displacement, it will be displacement is equal to r times the angular displacement, like that. So this is the relationship. Now why are we finding v? Because we need to replace for v here. What is the value of v there? Then we are going to look. So this one, remember what we said, angular, if you look at the speed is equal to distance over time. So even this one, even the angular speed will be equal to the distance, or rather displacement. In this case it will be the angular displacement over the period. Now this is the period they have given us. Now what is this? It is making a complete circle. Now since it is making a complete circle, it simply means to say if it's making a complete circle, the angular displacement is a 2 pi. So we are going to say this one, this theta will be 2 pi over the period, like that. So this is what we have. So we are going to say the velocity should be equal to, we are going to say velocity is equal to r times the 2 pi over the period, like that. So we have everything. So that means if we wanted to use the angular form, we can say the 2 pi over the period. Find it separate if we wanted the angular form, which so that is that. So this equation, if you want, you can find the velocity. Then if you want the angular form, you can divide by r. This, don't write this to make your omega to be v over r, but we are not going to do that because that's not the one they have told us to find. So we are going to have our v should be equal to, what is our radius? Our radius is equivalent to 5, or our radius is equivalent to 1.25. so we get this and write 1.25. If this was the distance, then we could have if it was the distance, then we could have said it would be L sine of our theta. So now since it's not the distance, if it's not the distance, and remember, if it is just like an horizontal circle like that, like without an angle, then we consider the length to be the velocity. So after doing this, we are going to say 1.5 times our 2 pi over the period. We are told that it's 3 seconds, so v should be equal to, period should be in seconds, so we have 1.25 times 2 pi. This gives us a value that is equivalent to 7.85 over 3. So the velocity will be equal to, when we divide our 7.85 divided by our 3, we are going to get a value of our 2.62 meters per second. So this is our speed. So with that, knowing our speed, we are going to say, what are we even looking at? The tension. So we need to find what this value is. Or the tension, sorry. We need to find what this value is equal to. So in this case, we have two equations. We cannot find the tension directly because we don't know the angle. So what we are going to do is that we are going to get these two equations, divide them, or get them from here. We have the T sine of theta should be equal to mv squared over r. We also have the T cosine of theta should be equal to, what do we have for the cosine of theta? This should be equal to, we have our T cosine of theta is equal to, what do we have? T cosine of theta is equal to mg. T cosine of theta is equal to mg, like that. So what we are going to do is that always the one with the cos is the one that you divide into there so that you can make tan. So we are going to have our T sine of theta should be equal to mv squared over r. So we have our T cosine of our theta, we have our mg, so we are dividing. So we have this and this cancel. If m was down, if m was here, it could have multiplied because they are both on the denominator. But since the m is up there, it means this and this will cancel. What are we remaining with? So we are remaining with the sine of theta over the cosine of theta should be equal to, we have our v squared over r. Then what we are going to do is that we are going to divide our g. Now instead of wasting time dividing, we can just multiply and say, remember that division, when it becomes multiplication, it becomes 1 over. So we have sine over cos is our tan of theta should be equal to v squared over r times g. It will be rg, like that. So this is basically the equation that can help us find the angle. If you want, you can just make this, the one that is having cos, to make t the subject of a formula. Even that works, where you can take this, you are going to still arrive at the same conclusion, where you have, if you take it like this, anywhere is very much possible and is very much okay, where you take the T cosine of theta to be T, you divide by cos theta, you divide by the cos of theta. So this will be T should be equal to mg over the cos of our theta, like that. So where there is T there, you replace now. So you are going to replace, that's how it works. If you do that, so it will be mg sine of theta. Then where there's cos, you say cos of theta should be equal to mv squared over the r, like that. So this gives us our mg. Then we have our sine of theta over cos of theta is tan of theta should be equal to mv squared over r. As long as they are on both sides like that, both of them are the numerator, you can cancel them. So we have our g tan of theta should be equal to v squared over r. So you divide your g. Dividing your g means it comes down here and multiplies that. So we have, this is what we have, our tan of theta should be equal to v squared over gr or rg. So you can tell that we are coming back to the same conclusion. Then take the tan and say theta is equal to tan inverse of your v squared over rg. So theta should be equal to tan inverse of what is your v squared. So your v squared is equal to your v squared. We found the velocity to be 2.62. So we square this over what is the radius. Radius is 1.25 times the 9.8. So this gives us, we have the tan inverse of our 2.62 squared. This gives us a 6.8644 divided by our 1.25 times our 9.8. This gives us a value that is equivalent to 12.25, like that. So our theta should be equal to, we have the tan inverse of 6.8644 divided by 12.25. This gives us a value of our 29.3. So we have 29.3 degrees. So with this angle now, you are able to find the tension. So yeah, it's a lot of work, but as you get used to it, it will be very much easy. So you are going to say your tension. Remember, which equation can we use? So now that you have the angle, you can either use this or you can use this. I think this one is much easier, but both of them will still give you the same answer. So use whichever is easier. So we are going to use this equation. So when we use it, we are going to have something like our t cosine of theta should be equal to our mg, which gives us t, if we divide the cos so that we remain with the tension, cos of theta, we have our tension should be equal to mg over the cos of theta. So tension should be equal to, what is our mass? So our mass in this case is equivalent to 5 kg. So we are going to have our 5 kg by our 9.8 over newtons per kg over what we are going to have as our cos of the angle. What is the angle? So the angle is, why am I even going this one? The angle was found to be 29.3. So we have 29.3 degrees. So our t should be equal to, on top, it will be 5 by 9.8, which gives us 49, over our cos of 29. So our cos of 29.3 gives us an angle of 0.872. So our t should be equal to 49 divided by 0.872. So we have our value to be equal to 56.19, like that, newtons. So this is our force, our tension there. So let's move on to our next question. So this one says a simple pendulum of mass 0.02 kg suspended from a string of 0.5 meters long is whirled in a horizontal circle. It is effectively a conical pendulum of radius 30 centimeters. Figure 7.9.3. Calculate the tension T in the string. So how do you deal with this one? So same approach. Okay, so let's do it here. So we have the T cos of theta. So the theta is also here, it is the same. So this one will be our T sine of theta, like that. Downwards will be our mg, like that. Now, what do we want? We want the tension T. So knowing that the tension T, we can find the T sine of theta to be equal to MSc, or we can find our tension cosine of theta minus our mg should be equal to 0. So we have our T cosine of theta should be equal to mg, like that. So otherwise, this is what we have. Now, we don't have the angle, but you must analyze, are you able to find the angle before you go any further? So what have they given us? They have given us the distance of it is 0.5, so we are told that it's 0.5. Now remember, the radius from here up to here, it is equivalent to, if you take the radius is equal to L sine of theta. Remember, theta is here, so the opposite will be sine. So this L is 0.5, so you can find the radius. So when you find the radius, you are able to find the angle. Why is that? Because you can use any trigonometric ratio. You know that the tan theta is equal to opposite over adjacent. Cosine of theta is equal to adjacent over hypotenuse. You can use any of the trigonometric ratios if you know two sides. So that is what we are going to do. Let's find what r is equal to. So in this case, r is equal to L sine of theta. L is equal to 0.5. Okay, so we don't have, we have been given the radius. Why are we even bothering ourselves? So the radius is given as 30 centimeters, and 30 centimeters converted to meters, it means since the centimeter is down here, you put the centimeters, it is up there, so you put the centimeters down, because there are 100 centimeters in 1 meter. So whatever is on top, put it down here, then cancel the units. It will be 30 divided by 100 is 0.3 meters, like that. So this gives us 0.3 meters. So the radius is 0.3 meters, knowing that the trigonometric ratio that you can use, opposite over hypotenuse, is sine. So you can say the sine of theta is equal to opposite over hypotenuse. So the sine of theta is equal to, what is our opposite? Opposite is 0.3 over our hypotenuse, which is 0.5. So this gives us a value of, you take the sine there, it will be theta is equal to sine inverse of 0.3 over 0.5, like that. So our theta should be equal to, we have the sine inverse of our 0.3 divided by 0.5. This gives us an angle of 36.87 degrees. So if that is the case, we have the angle, and the simplest formula we can use is this, because the only thing that was missing was the angle. So we are going to say T cosine of theta is equal to mg. We divide the cosine of theta, we have our T should be equal to mg over the cosine of theta, which will be, T should be equal to, what is our mass? Our mass is equivalent to 0.02. So we get our 0.02 times our 9.8 over the cos of the angle, which is 36.87, which gives us T should be equal to, so our 0.02 times our 9.8, this gives us a value of 0.196 over our cosine of, so our we can just say cosine of 36.87, then press. Our tension will be equal to, so we have our 0.196 divided by, put them in brackets, the cosine of our 36.87. This gives us a value of 0.245 newtons, like that. 2.45 newtons. So with this we have found the tension there. Then the other one, the angular frequency. Remember, angular frequency is just the same as the angular velocity. The only difference is that angular frequency is considered to be a scalar, whilst the angular velocity is considered to be a vector, but the formula is the same. So the angular frequency will be given by this formula. we have the angular frequency should be equal to 2 pi over the periods. Remember that formula, which is the theta over the period, because that's how we find the speed. Now the angular speed will be this. So this is our formula like that. Now, do we have the period? We don't. Do we have the period? We don't. But we can take advantage of this equation, because this equation can give us the velocity and consequently give us the angular. So this is what we are going to do. So if we had the displacement, we could have used it. So we have our t sine of theta should be equal to our mv squared over the r, remember. Then v, if you recall, v is equal to r times the angular form. So that means to say we are going to get this substitute. So it will be t sine of theta should be equal to m. Then where there is v, we put rw squared over what is our radius. So we have the radius like that. So the t sine of theta should be equal to what is our mass. We have the mass. Then we have our r to the squared like that. Then we are distributing the squared, w squared over the r. So this and this cancels. So we are going to have our t sine of our theta should be equal to m w squared r. Now, if I want, I can just put my Mr. like that. Mr. w squared over, yeah, just like this, because this r was cancelled like that. Now we want to make this the subject of a formula, because that's the one we want. So this gives us over the Mr. So you just have to be playing around with equations. So w squared should be equal to t sine of our theta over our Mr. like that. So we find the square root. This and this cancels. We have the w should be equal to the root of our t sine of our theta over the Mr. So our w should be equal to the square root of what is our t. Our tension in this case would be equivalent to, so our tension in this case would be equivalent to, what's our tension? Tension was found to be 0.245. Then we have the sine of the angle. We found it to be 36.87 over our mass. What is the mass? So the mass of this is equivalent to 0.02. So we are going to put 0.02. Then the radius was 0.3. So we have our w should be equal to, we have our 0.245 times sine of 36.87. This gives us a value of the root of 0.147 over our 0.02 times 0.3. This gives us a value of 0.00. Okay. So according to my calculator, don't want to make a mistake, it's giving me 6 times 10 to the power negative 3. So we have, this should be equal to, so when we divide our 0.147 divided by our open bracket 6 times 10 to the power negative 3, this gives us a value of 24. So we have the 24.5. So our w should be equal to the root of 24.5 gives us a value of 4.95 like that. So this will be the radians per second. So this is what we have. So just be critical. So that's the angular. So if you don't know, that's the angular. If you don't know what the angular frequency is, it's just the same as the angular velocity like that. Let's look at our last question. So we have this. We are told a body of mass 5 kg is attached to a string of length 1 meter and moves in a horizontal circle as shown in figure 14.1. A is 40 centimeters vertically above B. So from here up to here it's 40 centimeters. Then we are told this arrangement is called a conical pendulum. Find number 1, the angular speed, number 2, the rotational frequency, and number 3, the tension in the string. So the first thing that we need to do is find the angle. So find this angle. Now they have already given you the 40 and they have 40 centimeters, and they have given you the length of the string is equal to, we have 1 meter. So since this angle is in contact with this 40 with this side, it means we can use cos, because cos of theta is the one that is equal to adjacent over hypotenuse, like that. So replacing, we are going to have our adjacent, which is the 40 centimeters. So the 40 centimeters, then 40 centimeters times the centimeters are on top, so they should come down. So we have the centimeters on top, we have the meters. How many centimeters are there in 1 meter? 100. So this and this cancels. 40 divided by 100 gives us a 0.4 meters. So we are going to use that. So it will be 0.4 meters over the hypotenuse. The length is of the hypotenuse is 1 meter, like that. So this gives us the cos of theta. 1 doesn't change anything, so it will be the cos of theta should be equal to 0.4. Take the cos that side, it will be equal to, theta should be equal to cos inverse of 0.4. When we press cos inverse of 0.4, it's giving us our 66.42 degrees. So this is our angle, like that. Then to find the angular speed, we need to be very, very careful. We know that the angular speed is equal to, or should I say the angular velocity is equal to this, which if you want the angular speed, which is this, it means make it the subject of the formula. You divide by r, you divide by r. So your W should be equal to V over the R, like that. So it is always good to write your equations. Now since to find the angular, we need the speed, we can, it means to say use those 2 equations. So it's always good to write them down. The T cosine of theta should be equal to the cosine of theta. If you have caught up by now, we are equating this to mg. Then the T sine of theta should be equal to mv squared over the r. If you want, it's msc, which is still okay. So this is what we have. Now we have the angle. Do we have the mass? Do we have the mass? Do we have the mass? 5 kg. So if we want, we can answer the third one. If we want, we can find the third one. But let's just begin with the first one, the angular speed. So finding the angular speed, as you can see, let's first find what this velocity is. If you want, you can still replace V is equal to RW and find it direct. It is still okay. You find it direct by replacing where there's V, you replace this. It is still okay, but yeah. So what we are going to do is we make this the subject of a formula. The one with cos is the one that you make, so that you have T, our over cos of theta over our cos of theta. We have our T should be equal to mg over the cos of theta. Now where there's T you put, so it will be in here, it will be our mg. It will be our mg. Then we have our sine of theta. Where there's T, we have put mg over the cos of theta. But even if you were to move it here, it is still the same. It is still the same. So that's why we move it there. Then put over that should be equal to mv squared over the r. So this and this cancels. we are going to have our g sine over cos, it is tan of theta should be equal to our v squared over the r, like that. So our g, we cross multiply, we are going to have our r times g tan of theta should be equal to v squared. You know how to derive this equation, they can ask you. So we have the square root, like that. So this is the velocity, so we have the square root of our rg tan of theta should be equal to the velocity, like that. So this is the equation, very important. They might ask you, show that the speed of the conical pendulum is this. So after you have done that, you are going now to substitute. This should be equal to, what's our r? Do we know our r? R is r known? Is the r known? So r can be found as r. If you want, you can replace r is equal to L sine of theta. Don't forget that. I've already explained why the opposite is, so if this is our L, the opposite would carry the sign. So, and this opposite is the radius from here up to there. So now we have this. If you want, you can just replace. You can replace where there is r, you put L sine of theta times our g tan of our theta, like that. If you want, you can just find the value of r separate, then substitute. It is still okay. So we have our v should be equal to the square root of, what is our L? The length is 1. The length, remember the length of the chord is 1. Sine of the angle we found was 66.42 degrees. Then we have times our 9.8. If you're not good at pressing the calculator, it's better you answer what your r is equal to L sine of theta. You find whatever it will give you. If your r is equal to 0 point something, let's say 1, then just replace where there is r. It is still okay. Then you have the times the tan of, what's our angle? Our theta is 66.42, like that. So our v should be equal to, so multiply what is inside, press everything together. So it's sine of 66.42 times 9.8 times the tan of our 66.42. This gives us a value that is equivalent to, we have the root of, is this what I'm getting? So let me press again. Sine of 66.42, 1 times the sine of 66.42. Don't forget to close the brackets. So this, first press like this in one bracket, then we have times the 9.8, which is after times 9.8, it's 8.98, then times the tan of the angle 66.42. This gives us a value that is equivalent to 20.58. So the square root of 20.58 gives us a value that is equivalent to, we have a 4.54, like that. So this is our speed. So with this speed now, they wanted the angular speed. So they want the angular speed. So you can now use this speed and say the angular speed. So the speed is connected to the angular speed by the formula r times w. So you divide by r, you have found your angular speed to be equal to velocity over r. So your angular speed is equal to what is your velocity. So your velocity has been found to be 4.94 over what is the radius. So we are still forced. You have L sine of theta. but you can just find it. Its R should be equal to L sine of theta. So just find, I think finding will be much easier and it will prevent mistakes. So the L in this case is 1 sine of the angle, which is 66.42. So the 1 sine of 66.42, we are going to get a value of R should be equal to 0.992 meters. So you can just now replace, even if you were to do that, it will still be the same. So we have 4.94 over our R, which is 0.92. So we are going to have 4.94 divided by our 0.92. This gives us a value that is equivalent to, we are going to get, oh, there's a slight mistake. The velocity was found to be 4.54, not 9. 4.54. 4.54. So our W will be equal to 4.54 divided by 0.92. This gives us a value that is equivalent to, we have a 4.935 meters, not meters, but radians per second. So that's our first part. Then the second part says, find the rotational frequency. Is just that normal frequency, which is the number of rotations per second. Frequency is the number of rotations per second. Now we don't know the number of rotations, so we are going to use knowing that we have found. So if you have failed the angular frequency, it means you will also fail this other one, or the angular speed. So knowing that the angular speed is equal to 2 pi over the period, and remember we said that this should be equal to 2 pi times the period is, this is the same as 1 over t. I've just moved it, but it's still the same. If we multiply this and this, we are going to come back to that. So W will be equal to 2 pi. Remember, 1 over period is the frequency. So this is the formula. They want the rotational frequency, which is this. Angular frequency is this. So we are going to divide over our 2 pi over our 2 pi. So our rotational frequency will be equal to the angular frequency over our 2 pi, like that. So what is our angular frequency? Our angular frequency is equivalent to 4.935 over the 2 pi. So the rotational frequency will be equal to 4.935 divided by our 2 pi. This gives us a value that is equivalent to, okay, so be careful when you're pressing 4.935, put these in brackets. I've made a mistake, so I've noticed that. So put them in brackets. So we have 4.935 divided by, open brackets, 2 pi. This gives us a value that is equivalent to 0.785, like that. So 0.785. The units are Hz. The final one is the tension. Now remember, we have two formulas that we are using. So the two formulas to find the tension, we have our T sine of theta, which should be equal to mv squared, or msc, and we also have T cosine of theta should be equal to, we have the tension, which will be our mg. So I prefer using this because everything is easy. So we have our T should be equal to, this cos divides cos of theta, cos of theta. This gives us our mg over the cos of our theta, like that. So our tension should be equal to, what is our m? our mg, our mass, is equivalent to, what's our mass? Our mass is 5 kg, so we are going to say 5 kg. We're going to say our 5 kg times 9.8 over the cos of, what is our angle? So our angle is equivalent to, what's our angle? Oh, we found the angle. It was 66.42. So we say 66.42. So just put these in brackets while you press on your calculator. So we have 5 by 9.8 will give us 49 over the cosine of our 66.42, which gives us t should be equal to, we have our 49 divided by our cosine of 66.42. This gives us, we have 122.49, like that, 49 newtons. So that is that for this video. I hope it was helpful. Kindly subscribe so that you don't miss out any important content like this, and see you in the next tutorial.